In this video, we'll talk about what it means for something to have a zero exponent or a negative exponent. Now, highly recommend before you dive any further into this video that you watch the videos on the product rule and the quotient rule, as both of those will lead into this video. So let's take a look at what a zero exponent means. So like for instance, let's say we have 10 to the 0 power. Now what does that mean? Well, let's take a moment and think about our quotient rule. So say for instance, we have 10 to the third power divided by 10 to the third power. If we follow our rule, meaning that since we have same base, we can subtract the exponents, 3 minus 3, which means that this expression is 10 to the 0 power, meaning these two expressions are equivalent. Now, if we think about this, 10 to the third power, that would be 1,000 if I was to run it out. But most importantly, these two things here are equivalent. If I take anything and divide it by itself, I get 1. Since all of these things are equal, 1 must be equal to 10 to the 0 power. And that creates a rule for us to be able to use. Anything to the power of 0 is 1, always. Doesn't matter if it's 10, doesn't matter if it's 50, doesn't matter if it's x, whatever it is, it's always 1. And this is why. So a zero exponent just means that you're taking something, dividing it by itself, therefore it's 1. So if we're looking at a negative power, what does that mean? So for instance, let's say we have 5 to the power of negative 4. Well, I don't know what that means, but if we go back to our quotient rule, we can do something kind of similar like we did with the zero exponent. So if we think about, let's say 5 to the second power divided by 5 to the sixth power. Well, we can think this out and say, okay, 5 times 5 for the top, and then we'll have 5 times 5 times 5 times 5 times 5 times 5 for the bottom. 2 of these are going to cancel, leaving me a 1, which means that this is going to be equal to 1 over 5 to the fourth power. So I can take 1 divided by 5 to the fourth power. That would be one way of looking at it. Now, if we follow our rule here, the bases are the same, therefore I can subtract the powers. Remember, order matters here. So this would be the same as 5 to the power of 2 minus 6. And you may be thinking, hey, that's 5 to the negative 4. All of these things are equal, therefore 5 to the negative 4 must be the same as 1 over the power of 5 to the fourth. And it is. So we can rewrite it with a positive exponent, but we have to rewrite it as a fraction. Now you might be asking yourself, okay, great, so I can rewrite it as a positive exponent. What do I do with it? So let's say, for instance, we wanted to evaluate, oops, I made a righto there. Let's say we wanted to evaluate 2 to the negative fourth. Well, I can think to myself that would be the same as 1 over 2 to the fourth. Because I don't necessarily know what a negative exponent means, but I do know what a positive one means. And if I think about it, 2 to the fourth, well, that would be 2 times 2 times 2 times 2, which there's a lot of ways you can go about it. You can go through and say 2 times 2 is 4, times 2 again is 8, times 2 again makes 16. You can make groups. 2 times 2 is 4, got 2 of those, take 4 times 4, that'll make 16. Either way. So then if I'm trying to figure out what 2 to the negative fourth is, well, that's the same as 1 over 2 to the positive fourth, which we know 2 to the positive fourth is 16. So 2 to the negative fourth is 1/16 as a fraction. Now, generally speaking, when we're looking at negative exponents, they're going to be a fractional value between 0 and 1. They'll be a decimal or a fraction. Either way would be fine. So that'd be one reason, one application of a negative exponent. The zero exponent, I would go through an example here, but there's always just 1. If you see anything to the 0 power, it's always 1.